Hello, everyone. Glad to be back here on stage at Open Source Observability Day. And today I'd like to talk to you about OpenSearch, the open source path for search and observability. My name is Dotan Horovits. I'm an OpenSearch ambassador. Actually, the tweet you see here on the screen is from last year's OpenSearchCon Europe that was held in Berlin. And we have OpenSearchCons around the world, North America, Europe, and other locations. I also am the host of the Open Observability Talks podcast. So already 6th year. So that's a favorite conference of mine, Open Source Observability Day, because that's a passion area of mine. I'm a senior developer advocate at the AWS open source team with a lot of focus on OpenSearch project and also in open source observability. I'm also an CNCF ambassador in the Cloud Native Computing Foundation with a lot of work around observability related open source projects. And in general, you can find me everywhere at Horovits, as you can see, Twitter, Mastodon, Blue Sky, Medium, whatnot. So feel free to reach out also after the conference. And let's start with a bit of a background on the OpenSearch project. OpenSearch started as a fork of Elasticsearch back in early 2021 after Elasticsearch was relicensed along with other components of the Elk stack to a non-open source license, to SSPL. And users, of course, still wanted an open source alternative for search, analytics, and observability workloads. And AWS stepped up and led the fork of the project. So the fork was the fork of the last Apache 2.0 licensed Elasticsearch 7.10, along with Kibana. And that was 4 years ago. And I'm glad to say that the project has come a long way in these past 4 years. As you can see, the numbers speak for themselves. The project has had over 1 billion downloads to date, more than 26, I think, so closer to 30 releases across 140 GitHub repos, really a massive project. And really, this is all thanks to the community, which powers OpenSearch through contributions. We have more than 95 organizations who build products and services with OpenSearch. We've partnered with project, more than 4,000 members in a very active public Slack, more than 7,000 users on the forums, and thousands of contributors from dozens of different organizations. So, and the results really speak for themselves. If you go to DB Engines, you'll see OpenSearch is the 4th ranked search engine, has been that way for quite some time. So the project truly has come a long way in these past 4 years. Big news that came from a year ago, in September 2024, the OpenSearch project became part of the Linux Foundation. So it's now a top-level project under the Linux Foundation, and we founded the OpenSearch Software Foundation as a non-profit under the Linux Foundation to foster open governance and open collaboration. So OpenSearch is an independent, vendor-neutral project, not owned by any vendor, a neutral playground for collaboration. We have the governing board in place and technical steering committee for the technical leadership with members from many companies. And I'm glad to say that organizations such as Uber, SAP, NetApp, and many others have already joined and are now helping us steward the future of the OpenSearch project. So this is about a bit of a background on the project and the community. And now let's talk about the tech stack. So what is in the OpenSearch stack? First and foremost, of course, there's the OpenSearch core. That's a distributed search engine built on Apache Lucene with document storage and indexing capabilities and with built-in vector database. So essentially you store documents, think about JSONs containing potentially unstructured text, as well as other data like geospatial coordinates and so on. And then you can query the data with a simple API. The next component is the OpenSearch dashboards. That's an open source data visualization toolset and user interface where you can run queries on the data visually. You can create dashboards, visualizations, alerts. You can manage your team collaboration, workspaces, and all these things. And the last component that I would like to mention is Data Prepper, which is a lightweight data collector for enriching, transforming, and aggregating your data. These are the main components. There are other client libraries, integrations, and so on that I will mention also later. And by the way, you can run it on Kubernetes. If you're a Kubernetes native, you have Helm charts and everything to do with that as well. OpenSearch has several primary use cases. First, OpenSearch is a search engine in its core, so many use it as a search engine for enterprise search, e-commerce sites, and things like that. Also, many use it as AI and ML for AI ML powered applications, thanks to its vector database and the integrations it has with the AI frameworks such as LangChain, Llama Index, and so on. Some use it for security analytics to help detect, investigate, and respond to threats in real time. And what we are all interested in this conference is the usage for OpenSearch for log analytics and observability use cases. So I'll definitely put most of my time in this talk on this area. But let's say a word about search, because search is also the engine behind it. So just to understand, search engines essentially match terms to objects in a catalog, like the example you can see here on the screen, asking about convertible olive couch in an e-commerce site, and it then searches the name of the product or the product description or whichever fields there are. So matching free text or structured data, essentially doing lexical search, keyword-based search based on term frequency on occurrence models. And then the relevance of the result is determined and determines the sort order. So you don't just get the results, you get them sorted according to how relevant they are to your search terms. That's one aspect. There's also aspect of facets that let users drill into the search results to narrow by attribute value. That's usually what you see on the left-hand bar when you tick boxes, because you say, okay, I want to search couches from specific material, specific color, brand, style, whatnot, and then it zooms in. It supports geospatial coordinates, so you can search for documents that fall within a defining bounding box or shape and so on. There's fuzzy matching, like looking for close words. Think about one letter got accidentally changed or dropped or whatnot, and you still want to find the term. So, and as I mentioned, also vector search. So not just lexical search, but also semantic search, where you represent the unstructured data as vector embeddings in a multi-dimensional space, and then you run similarity search on that vector data. So that's search. And now let's talk about observability. On the observability front, you can use OpenSearch to detect, diagnose, and remedy issues that affect your performance, scalability, availability of your application or the infrastructure. Many use it for log analytics. So you have the discover pane where you just run queries on your log data and get the answers from there. You can create dashboards. You have features such as log tail, log surround, log patterns, and so on. You can query your data with Lucene or with PPL languages. PPL is the piped processing language, an open source query language that we developed as part of the OpenSearch stack that can query across the different signals, so not just logs. And also one of the cooler things that we've added recently is natural language translation. So you can actually query in natural language and have the query generated for you. So a great use case for AI for observability. It also integrates natively with other cloud-native observability projects, as you can see. So you can build observability pipelines with telemetry data using the OpenTelemetry standard and native OTLP endpoints. There's support for Jaeger trace data, so you can use OpenSearch's built-in trace analytics capabilities as a backend for your Jaeger trace data. You can use OpenSearch to visualize metrics data from Prometheus, and so on. So that's about it, but let's have a look. I prepared a short demo to show you what it looks like. In this case is a demo of a web traffic monitoring dashboard. So this is a dashboard that you would build. You can see things such as unique visitors. You can see the breakdown of visitors by operating system, how many Windows, how many OS X, and so on. You can see the response codes over time. And then you see also these vertical bars for incidents in this case. So security issues. And then you can see how security issues correlate to the response codes. You can see the unique visitors versus average bytes in this example to see how they correlate to each other. You can have a look and see the different file types that were downloaded, how many CSS, how many GZ, how many zips on scatterplot or on a table. You can see a heat map of where your website was hit the most, and you need to cater for high load and where from around the globe with an interactive map. Of course, you can filter the entire dashboard for specific source countries, or it could be also on specific operating systems that users logged on from, maybe even on specific range of transmitted bytes. So, and all the dashboard is immediately, of course, being filtered to these parameters. And of course, you can filter the time frame. So now it was last week, we can make it the last month, for example, last 4 weeks, and immediately again we'll see a different time range for that end. So you see the filters added at the top, the geospatial filters, the machine operating system keyword, the byte range, where the numeric keyword, geospatial, you see different types of filters on different types. So that's just a brief taste of that case. And now I'd like to talk about the architecture when you run observability with OpenSearch. So with Data Prepper, you can ingest, enrich, and transform your data collection so that they're optimized for analysis, and then you store and index and store the data in OpenSearch core across the different signals. And then the piped processing language, PPL, is the query language that is optimized for observability use cases that you use to query the data and make the correlations and analysis between the different signals. And then you have on top of that the UI that enables easy visualizations of the data across dashboards and so on for fast root cause analysis, essentially. And talking about the UI and UX in general, one of the biggest areas of focus of development in the project has been the UX, because the sheer volume and complexity of observability data, as we all know, definitely in this forum, can be overwhelming. So OpenSearch wants to provide you with powerful, easy to navigate tools to manage and visualize your data, to identify and respond to issues quickly, to share insights within your team, across teams, and all of that has to be accessible and is simple to manage permission control. So that's what we're trying, and you see different on the slide, different capabilities to support that. The screenshot, by the way, is from the anomaly detection feature, another great example for AI in the service of observability, where instead of using static alerting thresholds, you can actually have a machine learning model that you can train with your traffic and your signals, and then it learns the normal behavior, and then it can flag anomalous behavior as dynamic alerts. And to give you another taste of the observability capabilities, I prepared another demo, this case about the service monitoring, the service maps, and the tracing capabilities. So service performance monitoring, if you like. So what you can see here is a map, a dynamic map that generated from your trace data about the different microservices and the interacting microservices and the connectivity between them. You see the coloring code that detects the duration. So the darker colors are the higher duration or request rate or error rate, the red metrics, so that you can zoom in. For example, in the request rate, you can zoom in on the ones that take the longest, that get the most request rates. In this case, it's as you can see, the front end. We can see the list of the different services also on the map view with the different red metrics for each one, and the connected services and the traces and so on. And then you can zoom in. For example, we talked about the front-end service. We can zoom in and see only the subset of the map, downstream and upstream services from that, and the red metrics for that specific service. We can also go into the trace analytics and see the different traces grouped by different types, like the HTTP GET and POST and so on. And then we can look into specific trace and see the timeline, like Gantt chart, like we do with any tracing tool. We can zoom in on the specific areas of focus and then start investigating our trace and understanding where are the long-running traces, where they come from, where the errors lie, and so on. So this is the trace analytics part in the observability capabilities of OpenSearch. Now, let's talk about the ecosystem, which is another important area of the project, because every monitored system has its own requirements, right? The data sources, applications, storage, processing requirements, and so on. And with OpenSearch, we want to be able to tailor your observability pipeline to suit your data and infrastructure and your observability goals. So it comes with easy integration with popular tools for collecting, managing, and visualizing information, such as the one shown here on the slide, and many more. I mentioned before that search is evolving from lexical search based on keywords into semantic search based on meaning and intent. So OpenSearch offers a full-fledged vector database for storing dense vector embeddings and running similarity search on them. So it supports both exact and approximate KNN algorithms. It supports multiple modalities, so not just text, but also images, videos, PDF documents with multiple modalities, and so on. In addition to the dense vectors, it also supports neural sparse search. You can bring your own LLM and plug it into OpenSearch as you see fit. There's a built-in MCP server for agentic AI and much more. So I have a whole different lecture just about the AI use case and the vector search and so on, but just to give you a taste of this side of OpenSearch as well. Performance has been another for the OpenSearch community, because a lot of users choose OpenSearch for its ability to efficiently manage and explore massive volumes of data. But with huge data sets, and as we all know, performance is always at a premium. So for user experience, for time to results, and also for cost savings, the cost of processing for indexing, the cost of storage, and access to the data, and so on. So we want OpenSearch to be the most performant search engine. And that's a lot of focus you see on different aspects: indexing throughput, query latency, storage space reduction, and much more. And I'll talk about performance also later. And now I'd like to talk about the hot news from OpenSearch. So even if you know OpenSearch and you knew all this background, now is the update. So the biggest news in OpenSearch has been a few months ago when we released the next major release of the project, version 3.0. That was the first major release in 3 years, so it was really exciting. And then in June we had the 3.1, and at August 3.2. And actually last week, October 14th, if I'm not mistaken, we released 3.3. Really exciting. We run an 8-week release cadence, so the project is moving very fast. And version 3 is really a big one. So I'd like to show you why. It starts with the underlying infrastructure, with Lucene and with the Java JVM engines that power OpenSearch. We've upgraded to the latest major version of Apache Lucene, version 10. We've also upgraded to JDK, so the minimum is now JDK 21. And this infrastructure upgrade gives many benefits, such as hardware level enhancements, SIMD vectorization, more efficient postings decoding, and more. Also, we've done, as you can see, on Node.js and others, and it's important these changes also make the project more future-proof. Also, one of the biggest evolutions come with how OpenSearch ingests, transports, and manages data. Okay, there are dozens of new features that contribute to this in version 3. I'll just give 3 examples that are going to make a big impact for OpenSearch users. One is about the gRPC and protobuf support that will allow you to realize faster and more efficient data transport and data processing for OpenSearch deployments and unlock data transport frameworks such as Apache Arrow and Apache Flight, which are optimized for large data sets and distributed networks. So a lot has been done on that front. Another one is pool-based ingestion, which gives you more control over the flow of data and when it's retrieved. So you can decouple the sources of the data from the consumers of the data. And that not only makes it easier to optimize for efficient ingestion, but also it means that you will be able to pull data from streaming systems such as Kafka, Kinesis, Pulsar, Red Panda, and whatnot. And another significant architecture change is the reader and writer separation. So you'll be able to keep your indexing and your search workloads separate. So think about log analytics users who want to scale their indexing to millions of documents per second, or enterprises that want to configure 20 plus replicas to support their e-commerce search traffic. This is the flexibility you get with the decoupling of the workloads. Continue on the performance improvement I mentioned before. With version 3 release, you're going to see OpenSearch performance take another big leap. As you can see here also on the latency graph going down on the slide. And actually, if you pay attention, to fit into, I use the logarithmic scale on this. So going down, this is logarithmic. This just to see what a tremendous performance improvement we got across the 2.x line, leading to 10x improvements with version 3. So really, really impressive results. Also, by the way, for those who are interested in the vector search, lots of improvements also on the vector search, like GPU accelerated vector search and showing like 9.3 times faster index builds and 2 times higher throughput, while reducing the cost by more than 3 times if you compare to the CPU based one. So really exciting stuff there. We've also enhanced query insights. So query insights is essentially a great way to investigate your long-running queries, to understand why it takes so long to run a specific query. You have a visual way to do this investigation. Also a smarter anomaly detection with contextual launch. Also, the new OpenSearch dashboards that was released in the very latest releases has dedicated workspaces for the different use cases, including, of course, for the observability use case. So you have a dedicated observability workspace, if you see on the left-hand side of the screen. And when you choose this workspace, that's the right-hand side of the screen on the slide. You can see that your navigation bar options and everything is already aligned to observability, with the different signals, insights, the sample data that you can deploy is observability data, and so on. And the latest release, by the way, also adds the React Flow library to OpenSearch Dashboards core. So you'll see many more very powerful visualizations leveraging this very robust library. We've also upgraded our tracing and correlation capabilities. So you have cross-cluster search for traces. There's a query trace data with discover traces view that includes like a click to filter interface, for example, allowing construction of complex PPL queries without having to write them yourselves manually. Talking about PPL, piped processing language, that's just to remind you, this is our open source unified language for querying across the different telemetry types. And now we've introduced new PPL commands, dozens of new commands. One of my favorite recent ones are actually working on querying nested JSONs and transforming nested JSON into tabular format for easier querying. Lots of commands around unstructured querying unstructured log data at query time, so you don't need to do without doing the pre-processing, analyzing time series data and the metric data, and new statistical functions, and a lot more on the PPL front. And also, by the way, I propose open source Apache Calcite has become the default query engine for PPL, starting OpenSearch 3.3, introducing better portability for a wide range of data management systems. So Calcite, a very mature framework providing new optimization capabilities, improvements to query processing efficiency, and also extensive library of new PPL commands. So a lot more is coming on the PPL. Stay tuned for that. And that's just a taste. There's a lot more in store for the 3.x line of OpenSearch. Like support for OpenTelemetry in Prometheus, support for natural language queries, a new APM experience, multi-source panels to overlay logs, traces, and metrics on the same canvas, defining SLO targets directly in the dashboards with real-time status indicators and automated reports, auto-generating alerts from your queries in Discover, and a lot more. So I actually had an episode about the latest major release at the Open Observability Talks on my podcast. So I hosted the governing board chair, Carl Meadows, and the 3.x release lead and technical steering committee member, Pallavi. So check out the QR code, scan it for the Open Observability Talks episode for a lot of good insights from the leaders of the project, essentially. Another really exciting news, fairly recently, just last month, we kicked off a new observability tag, technical advisory group under OpenSearch. It's been approved by the technical oversight committee, technical steering committee, sorry. And the purpose of the observability tag is to advance the best practices that help users effectively manage OpenSearch for ingesting, storing, and visualizing all these telemetry signals and help steer the technical direction of the stack in this regard. So if you're interested, scan the QR code. There's a blog post that describes the new tag, the mission statement, the charter, and how to get involved. We'd be happy to have more open source observability experts such as yourselves joining. It's open for all, including regular calls for the tag. Happy to have more folks chiming in and helping us steer the direction of observability within OpenSearch project. And I'd like to invite you to join us, not just for the tag, but generally on the OpenSearch project. You can join us on, obviously, the GitHub repo, the Slack channel. There's a Slack instance for OpenSearch, the forums, all of that online, but also in person. We have user groups. I think like at least 30 user groups around the world, different locations that meet and run meetups and so on. We also have the regional events, as I mentioned, the OpenSearch cons in North America, in Europe, in India. It's going to be actually next month. It's going to be in Seoul, in Korea, and then in Japan the month after that, and then in China beginning of 2026. So all around the world, regional conferences, really good ones. I recommend checking them out. I've put all the useful links in one place. Also Tech Talks, Playground, that you can play online with the tool without even installing it. Roadmap on GitHub, and many other things. So you can scan the QR code for just a list that I compiled for the useful links. And of course, I'm happy to also, if you want to reach out to me personally, as mentioned, my surname Horovits is my handle everywhere. So Twitter, Mastodon, Blue Sky, Medium. Obviously, I'm on the OpenSearch Slack. I'm also on the CNCF Slack. So feel free to reach out to me wherever relevant with questions. I'm Dotan Horovits, and thank you very much for listening, and enjoy the rest of the conference.